Rather than using rockets to launch satellites into orbit, would it be possible to get them up there by hauling them up a structure that extends into space? 11 of you guys thought that that might be halfway plausible, and the rest of you guys were like, no, that's bull, right? There's no way you can build a structure that tall. But it would be so useful if you could, right? Like, think about it this way. How much energy do you think it actually takes to get something up into space?
Quite a bit.
A lot, right? A rocket is like this, and pretty much the only part that's actually going to space is this little capsule up here. Like, this is the part that we're trying to get to space. All of the rest of this is rocket fuel. It must take tons and tons of energy, right? Well, think about it like if you could build a structure into space. Space is not that far away. People think that space is super far away. It's not that far away. The International Space Station, for example, orbits at about 250 miles above the surface of the Earth. And others, like low Earth orbit, is as low as 200 miles. That's super close. Imagine, again, we have a staircase. How long do you think it would take you to climb that if you're on foot?
Wow.
This question was actually asked of Randall Munroe. Remember I showed you guys that XKCD comic on Tuesday about the centrifugal force? That NASA scientist who draws that comic? Let me show you his response to this question. A week or two. World champion stair climbers can travel roughly a Mount Everest's height in a day. At that pace, taking the other 12 hours to rest, eat, and sleep each day, it would take them a little over a week to reach the top. Climbing all those stairs would burn calories, which means you need to carry food. It turns out that the most efficient food you can carry in terms of calories per pound is butter, which is why Antarctic explorers carry so much of it. Suppose your backpack holds 9 liters. Climbing 10 stairs burns about a calorie, which means climbing all the way up to space would burn about 72,000 calories. If you fill your backpack with butter, it would hold almost enough calories to get you to the top. There is enough energy in a large backpack full of butter to get a person into space. That's not that much energy. Why do rockets require so much darn fuel to get to space? If this was a totally efficient process to get a person into space, the amount of energy you need in rocket fuel is going to be roughly the same mass as that person. Do you guys see the problem? To get this guy into space, you need this much rocket fuel, this much energy. But now you've just doubled the weight of the system, right? So to get this whole system into space, you're going to need this much rocket fuel. Now you just doubled the weight of the system again. To get this much weight to space, you're going to need this much fuel. And every time you do a new iteration of it, it only makes a small dent in the problem. And eventually, by the time the problem completely goes away, you've got a rocket that's this large. This is known as the rocket equation. Rockets are grossly inefficient. So it would be super useful if we could just climb to space rather than launching rockets in space, right? Back to our Wanderers video for a second. Did you guys catch?
I love that video.
Species might be owed to a restless few, drawn by a craving they can hardly articulate or understand, to undiscovered lands.
Oh yeah, I remember that. I was wondering about that one.
It looks like that's a giant tower into space that's leading down to this little settlement right here, right?
Yeah.
So what's going on there? It's true that we can't build a tower to space. If we tried to build a tower that tall, it would collapse under its own weight. Can you guys think of a way around that problem, though? What if, how could you get a structure that tall without it having, or to support its own weight, I guess, without it collapsing under its own weight? Yeah?
Maybe something flexible that's tethered to a satellite in space.
Very good. So, imagine we have a satellite in space. If you can figure out how to make that satellite orbit Earth at the same rate that the Earth spins, it's going to stay over the exact same spot on Earth, right? And then you can just tie a tether between those two things. So, to be able to figure out how to do this, how to get a satellite in geosynchronous orbit, geostationary orbit, that's what it's called, we're going to have to learn a little bit about orbits. So, let's do that.